Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about question bank on polymer technology. So this first question is, define polymerization, explain the types of polymerization with examples. So polymerization, here polymer means from the Greek, poly means many, mer means parts. So number of parts combined to give polymer. So here polymer is a high molecular weight compound. So it is formed by the monomers. So mono means single unit. So monomer is a low molecular weight compound. So when it is undergoes polymerization, then form polymer. So monomer converts into polymer. This process is called polymerization. So here simply we say polymerization means a low molecular weight compound converted into high molecular weight compound. This process is called polymerization. Here monomer is a low molecular weight compound. So this number of monomeric units undergoes polymerization, then form polymers. So it is a high molecular weight compound. So monomer convert to polymer or low molecular weight converted into high molecular weight compound. This process is called polymerization. So here polymer is a substance that is made up of very large molecules that are in turn made up many repeating units are called polymer. Just now we discussed already. So monomer is a single part or single unit. So number of monomeric units are repeated several times, then give polymer. So usually monomer is a low molecular weight compound and polymer is a high molecular weight compound. So the conversion of monomer into polymer, that process is called polymerization. So here polymerization is a process through these monomers come together to form the macromolecules that constitute polymer. For example, polystyrene. Here styrene, it is a monomer. So number of styrene monomers undergoes polymerization. That means repeated the styrene monomeric units repeated several times here, then form polymer. This is a polystyrene. So styrene undergoes polymerization, then form polystyrene. This process is called polymerization, or otherwise ethylene. So ethylene monomer. So what is that ethylene monomer? CH2 double bond CH2. So a number of ethylene monomer undergoes polymerization. So same here, ethylene monomer repeated several times. So then form polyethylene. So the process is called polymerization. So polymerization means monomer convert into polymer, or otherwise low molecular weight compound converts into high molecular weight compound. This process is called polymerization. So based on synthesis, these polymers have been broadly classified into two types. So based on synthesis, these polymers are classified into two types, that are addition polymerization and condensation polymerization. So what is addition polymerization? It is also called as chain growth polymerization. So addition of monomers without eliminating any byproduct, only adding monomers. So this type of polymers are called addition polymers. This type of polymerization is called addition polymerization. So here these polymers formed by the polymerization of monomers. So it containing double or triple bond. That means only monomeric units containing unsaturated compound. That means double bonds or triple bonds. So only unsaturated compounds undergoes addition polymerization. So here addition polymerization means only addition of monomers without eliminating any byproduct. So this type of polymerization is called addition polymerization. Which type of monomers undergoes addition polymerization? Only the monomers which are containing double bond or triple bond. That means unsaturated compounds which are undergoes addition polymerization, then gives addition polymers. So here for example ethylene. So ethylene monomer when it is undergoes polymerization. So it is a monomer. When it is undergoes addition polymerization, then form polyethylene. So here only repeated ethylene monomers, only adding without eliminating any byproduct is called polyethylene addition polymerization. One more example is vinyl chloride. So number of vinyl chloride monomers undergoes addition polymerization. So here vinyl chloride monomer repeated several times, then form polyvinyl chloride. So in this addition polymerization, only adding addition of monomers without eliminating any byproduct. So which type of monomers undergoes this type of polymerization? So the molecules contain monomers containing double bond or triple bond. So that means unsaturated compounds which only undergoes addition polymerization, then form addition polymers. So this polymerization is also called as chain growth polymerization. Already we discussed previous class mechanism of addition polymerization. So in this chain growth polymerization, it's involved total 3 steps: initiation, propagation and termination. And next type of polymerization is condensation polymerization. So these polymers are formed by the 2 different functional group of monomers. So here these are formed by the 2 different functional group of monomers and elimination of byproduct. And with the formation of new functional group are known as condensation polymers. So condensation polymerization means these are formed by the 2 different functional group of monomers. For example, here the preparation of nylon 6,6. So nylon 6,6 is the best example of condensation polymerization. So how can you prepare nylon 6,6? It is formed by the adipic acid and hexamethylene diamine. So generally condensation polymerization means these polymers formed by the 2 different functional group of monomers. So here hexamethylene diamine, it containing amine functional group. Here adipic acid, it is present acid functional group. So here 2 different functional group of monomers undergoes this type of condensation polymerization, then form new functional group of monomer, that means amide bond is formed here. Amide bond is formed and eliminating byproduct. So water molecule is eliminating. So this type of polymerization is called condensation polymerization. So they are the best example: nylon 6,6 rolls, nylon fabric. So next example is terling. So it is also formed by the condensation polymerization. So condensation polymerization means it is formed by the 2 different functional group of monomers and eliminating byproduct. In this case, it forms new functional group of polymer. So here ethylene glycol, all one functional group, and terephthalic acid, acid functional group. So 2 different functional group of monomers undergoes which type of polymerization? Condensation polymerization. So condensation polymerization. So in this case, it forms dectra or terline and byproduct is water molecule. So this type of polymerization is called condensation polymerization. So based on synthesis, these polymers are classified into 2 types: addition and condensation. And next question is, explain the preparation, properties and engineering applications of phenol formaldehyde resins. So here bakelite, or it is also called as phenolic resin or phenol formaldehyde resin. So it is obtained by the condensation polymerization. So just now we discussed what is condensation polymerization. It is formed by the functional group of monomers and eliminating byproduct. So here this bakelite is prepared by the condensation polymerization of phenol and formaldehyde. So it is prepared by the condensation polymerization of phenol and formaldehyde in the presence of acid or alkali catalyst. So in this preparation, it is involved total 3 steps. So step 1. So the step 1 is the reaction between phenol and formaldehyde. Phenol and formaldehyde then forms orthohydroxymethylphenol or parahydroxymethylphenols. So what is the step 1? Here this is a phenol structure. So phenol reacts with formaldehyde. So in the presence of acid or alkali catalyst. So here in this case it forms ortho position, ortho hydroxy methyl phenol or para hydroxy methyl phenol. This is the first step for the preparation of bakelite. And next step 2 is when this ortho-hydroxy methyl phenols are heated with excess of phenols. So ortho-hydroxy methyl phenols heated with excess of phenols in the presence of acid catalyst. In the presence of acid catalyst. So in this case it forms novolac. It forms novolac. Next third step is for the heating of this novolac resins in the presence of curing agent. So what is the curing agent here? Hexamethylene tetramine. Hexamethylene tetramine. So it produces hard, rigid, insoluble, cross-linked polymer called bakelite. It is called bakelite. So total in this phenol formaldehyde resin preparation, it's involved total 3 steps. So first step is phenol reacts with formaldehyde in the presence of acid catalyst or basic catalyst. So here it forms ortho-hydroxymethyl phenol and para-hydroxymethyl phenol. So this ortho-hydroxymethyl phenol heated with excess of phenols. So in this case it forms novolac heated with phenol. Excess of phenols. So in this case it forms novolac. So this novolac is heated with curing agent, that is hexamethylene tetramine. So in this case it forms bakelite or phenolic resin or phenol formaldehyde resin is formed. So this is the preparation of bakelite. Now let's discuss properties of bakelite. So bakelite is a thermosetting plastic. So generally this bakelite is prepared by the condensation polymerization and it is a thermosetting plastic. That means only hard on heating. Once it convert hard, we cannot change it, we cannot remold it again. So the type of plastics are called thermosetting plastics. Therefore, when heated, this polymer is malleable or liquefiable. So however, when it's cooled, it becomes permanently hard and rigid. That means it is a thermosetting plastic. Thermosetting means hard on heating. Once it convert hard material, we cannot soft again. That is the meaning. And it is a non-conductor of electricity. It having dielectric constant of 4.4 to 5.4. And it is heat resistance and therefore non-flammable. So thus it functions as a good insulator. So bakelite is also resist to any kind of chemical action. So hence it is a non-destructive and it can be easily and quickly molded. So the molded of bakelite are fairly scratch resistant. Usually it has brown or amber color. However, it can be found in a variety of colors. So bakelite is distinctly sticky, sweet of finishy order. So these are the properties of bakelite. Now discuss what are the uses of bakelite. So it acts as a good insulator. So therefore, it is widely used in making several electrical devices like sockets, automobiles parts, switches, insulation wires, etc. So it also used in making of non-conducting parts of radios and telephones. So bakelite can be very easily molded. So thus it can be used for making a variety of daily use commodities like clocks, toys, chess poke, chips, etc. Machinery parts, adjunct sets, washing machine impeller buttons, kitchenwares, etc. We are preparing by using this material. So since bakelite is available in a variety of colors, so it is also utilized for making artificial jewelry like bangles, earrings and bracelets. So it is also widely used as adhesive or binding agents. So it is used in the varnishes and used as a protective coatings. So it is also used in making musical instruments like saxophone, whistle and electric guitar. So musical instruments also prepared by this bakelite material. Next question is, what are biodegradable polymers? Explain with preparation of biodegradable polymers with its applications. So first, what is biodegradable polymers? So generally, so many polymers do not undergo degradation. So even after long time also, some of the polymers do not undergo degradation. So it is very difficult to manage the polymer waste in the environment. So to avoid this, they are using biodegradable polymers. They degrade quickly and do not cause such environmental problems. So what is the definition of biodegradable polymers? These polymers are easily undergoes degradation by the naturally occurring microorganisms like algae, fungi, bacteria, etc. and do not harmful for environment. So this type of polymers are called biodegradable polymers. So what is the preparation of polylactic acid or polylactide? So it is derived from renewable resources. Renewable sources means such as starch, sugarcane, etc. So polylactic acid is a biodegradable and bioactive thermoplastic polymer. So that has gained significant attention as an environmental friendly, that means eco-friendly and alternative to traditional plastics. So it is commonly used for a variety of applications due to its biodegradability, biocompatibility and renewable origin. So that's why we prefer so many applications, this polymer used in so many applications. So how can you prepare this polylactic acid? So it is prepared by the catalytic dimerization of lactic acid. Catalytic dimerization of lactic acid, so resulting in the formation of lactide monomer. So this is the lactic acid. So removal of water then form cyclic lactide monomer. So catalytic dimerization of lactic acid resulting in the form of lactide monomer. So polymerization of lactide monomer in the presence of stannous octate to give polylactic acid. So this is the preparation of polylactic acid. Now discuss what are the properties of polylactic acid. So it is used for so many, so it is having a wide range of properties, so that makes it suitable for various applications. So first one is biodegradability. So this polymer is easily undergoes degradation and do not harmful for environment, eco-friendly polymer. So this polylactic acid is a biodegradable under the right conditions, so making it an environmentally friendly material. And biocompatibility. So it is safe for use in medical and food contact applications due to its biocompatibility. And transparency. So polylactic acid is transparent and can be used into clear glossy products. A renewable source. So it is derived from renewable source such as sugarcane, starch, etc., corn, etc. And rigidity. So it offers good rigidity. So it can be engineered to be similar in strength to conventional plastics. And heat resistance. So polylactic acid is moderate heat resistance. So but it may deform at relatively low temperature. So limiting its use in high temperature applications. Brittleness. So polylactic acid can be somewhat brittle, so which can be affects its use in applications require impact resistance. And barrier properties. It has reasonable barrier properties against moisture and gases. So these are the properties of polylactic acid: biodegradability, biocompatibility, rigidity, renewable resources, transparency, brittleness, barrier properties. So that's why it is suitable for so many applications. So what are the uses of polylactic acid? So polylactic acid used in so many applications because of their unique properties. So first one is packaging. So it is used for producing biodegradable and compostable packaging materials such as disposable cups, food containers and films. And next one is textiles. So these fibers are used in the textile industry to produce biodegradable and sustainable fabrics. Medical and healthcare. So it is used in medical devices such as tissue engineering scaffolds and drug delivery systems due to biocompatibility. And next one is 3D printing. So this polymer is popular material for 3D printing due to ease of use, biodegradability and availability of various colors. Next one is filaments. So it is used in the manufacture of filaments used for fused deposition molding 3D printers, FDM 3D printers. And next one is biodegradable films. So these films, polylactic acid films are used for agricultural applications such as mulch film, as they can be flowed into the soil after use. Disposal tableware. So this polymer used to produce disposable plastics. That means plates, bowls and utensils for single-use applications. And next, consumer goods. So this polylactic acid found in consumer goods like toys, cutlery and cosmetic packagings. So these are the uses of polylactic acid. And next question is, what do you understand about the vulcanization of rubber? So write the advantages of vulcanization. So it is this process introduced by Charles Goodyear in 1839. So he observed what purpose we are using this process vulcanization, because improve the properties of rubber. So in this case the compounds with same chemicals like so here this process is mainly used for improve the properties of rubber. So here the compounds heated with same chemicals like sulfur, hydrogen sulfide, benzyl chloride, etc. So most important is addition of sulfur. So this process was introduced by Charles Goodyear in 1839. So he observed that when rubber is heated with sulfur at 100 to 140 degrees centigrade temperature, so its tensile strength, elasticity and resistance to swelling are increased tremendously. So simply we say this process is used for improve the properties of rubber. So in this case sulfur, raw rubber treated with heating with sulfur at 100 to 140 degrees centigrade temperature. So in this case improve the properties of rubber. So such properties are like tensile strength, elasticity and resistance to swelling or increases tremendously. So all these properties are increased when this raw rubber heating with sulfur. So this sulfur combines chemically at the double bonds in the rubber molecules, bringing about excellent charges in its properties. Example, resistance to changes in temperature, increased elasticity, tensile strength, chemical resistance and durability. So here this is a rubber. Generally it containing natural rubber. It containing basic unit is isoprene. So this isoprene molecules undergoes polymerization, then form polyisoprene. So this is the isoprene chains. So then this is a raw rubber heated with sulfur at 100 to 140 degrees centigrade temperature. So in this case sulfur combines at double bonds of the rubber springs. So it forms sulfur crosslinks with double bonds of the rubber springs. So this is called vulcanized rubber. So this process mainly used for improve the properties of rubber like durability, elasticity, water absorption capacity. So water resistance, all these are improved when this natural rubber heated with sulfur at 100 to 140 degrees centigrade temperature. So here sulfur combines at double bonds of the rubber spring, then form vulcanized rubber. So this process was introduced by Charles Goodyear in 1839. So in this session, we'll learn about what are the important questions in this polymer technology. Like for example, vulcanization process, biodegradable polymers, types of polymerization, how can you prepare polylactic acid, how can you prepare bakelite, preparation properties, uses of bakelite. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.